Well, good day, everyone. All my math geeks, I want to share with you how to um, find prime numbers. So, I'm going to share my screen with you so that you could see how I do it step by step. And I'm going to make sure. There we go. So, I'm in my sketch pad. I'm going to start with the number. Well, we know 1. Whenever we multiply by 1, we always get the same thing, right? So we know 1 is not a contributing factor. It doesn't really contribute to the composition of a number. So what we're going to do is just forget about that and talk about how other numbers starting from 2 can help us discover new primes. So 2 is the next number after 1, of course, right? And 2 is the double of 1, right? When we double 1, we get 2. So in and of itself, it is it's a complex way of uh showing multiplication. It's the very first multiplication, but by addition. Okay, so then 2 and then 3, you know, are the next numbers. Okay. All right. So after you have 2 and 3, we got to figure out, okay, well, 2 is prime, right? Because you cannot really multiply 2 by anything and get something else. It is itself prime. Okay, so it can't be broken down, right? And neither can 3. These are the base prime numbers. So whenever we have multiples, that's when we create what's known as composites. So when we multiply 2, if we double 2, we get 4. That's the next number. Okay. So 4 is a multiple of 2, right? So it's 2, excuse me, times 2. All right. Easy enough. How about 3? When we double 3, 3 times 3, we say 6. So that's 2 times 3. Those are the factor trees. Something happens as we find the multiples of these first primes. We get a gap in our numbers. After the number 4, we know is 5. But for some reason, um 5 is discovered to be the next prime. Okay. It's a discovery zone because when we start multiplying 2 and 3, we find that there's a gap in the lineup of numbers, the consecutive numbers. Okay. And because of that gap, we find the next prime. So this is the most intuitive part of figuring out next primes. Okay. Is to get these multiples of the previous primes. And when we find the multiples of the previous primes, we discover the gaps. So really finding primes is really discovering the gaps in the lineup of numbers. Okay? So I want to introduce what's called the primorial. The primorial of 2 is just 2 itself. The primorial of 3 is 3 times 2. The primorial of a 5 is 5 times 3 times 2. So what we're doing here is multiplying all the prime numbers. That's what primorial is. So the primorial um is basically the product of primes. Okay? So we're going to look a little bit um into this. So we're going to talk about 5 sharp with the primorial 5, and then we'll kind of discover as we go. Okay, we're going to discover these primes as we go. First of all, let's kind of erase some of this stuff that's not needed. Okay. Okay, so now that we kind of illustrated the gap, now we can add 2, 3, and 5 as our in our prime list, right? So let me do this. I think the width of my pen is a little bit too much. Okay. All right. So here we have it. So now we have 2, 3, and 5 since we discovered 5. So in order to find the next prime, we actually have to look at the multiples. So we're going to find 5 sharp to be 5 times 3 times 2, which is 15 times 2 or 30. So we say that it's equal to 30. Okay, so 5 sharp is equal to 30. All right, that's all good. So we're going to find all the multiples up to 30. All right, so we're going to do the multiples of 2 up to 30, the multiples of 3 up to 30, and the multiples of 5 up to 30. It's just, we're going to skip count until we get to 30 for all of these. And the reason why we stop at 30 is because it is the primorial of a 5. So that's where they converge. That's where all of them are multiples of each other. It's divisible, the number that's divisible by all three primes. Okay. Okay. So I should say, yeah, the number where the factors all exist. So let's look at the multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. Okay, those are the multiples. Then, then we have the multiples of 3. So we're gonna have 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Okay. Now I'm going to put my multiples of 5 over here. 5, 10, 15, 20, 25, 30. Okay. Now look what happens. Well, we already know 1 is the non-prime, right? So our list of numbers, 1. So as we go along, I'm just going to kind of check off the numbers we have. And then if we discover another prime, I'm going to add it here. Okay. So let's say 1, 2, 3, 4. Oh, so sorry. Let me just restart. Okay. So we got 1, 2, 3, 4, 5, 6. 7 is not in the multiples. So we say 7 is the next prime. Okay. And then 8, 9, 10. 11 is not here. So it is the next prime. So then we have 12. No 13. So 13 is our next prime. 14, 15. Okay. 16. Oh, look, 17 is missing. So 17. Whatever numbers are missing from our multiples are the primes. Okay, so 17, 18, 19 is missing. So we'll say 19 is next. 20, 21, 22. Oh, 23 is missing. So 23 is our next prime. Okay. All right. So then After that, we got 24, 25, 26, 27, 28, and 29 is missing. So that will be the next prime. And actually, that is the last number before 30. And here's 30. So we were able to basically find all the multiples here and discover 7, 11, 13, 17, 19, 23, and 29. So we just found the next set of primes just by, skip counting on the previous primes. Okay. The next one we want to do, we want to add 7 to our lineup, right? If we add 7 to our lineup, we can discover the next set of primes. Okay, so 2 times 3 times 5 times 7. 2 times 3 times 5 times 7. That is 7 sharp. Which is equal to 6 times 5, which is 30. 30 times 7 is 210. Now we're going to discover the next set of primes up to 210. So we already know the multiples here. So we don't have to discover them again. We can start from 30, okay? And keep skip counting. So it's not like we have to reinvent or rediscover any multiples up to 30. So we can go from 30 to 210 when we do the multiples, all right? But this is just the beginning of how to discover the primes. And another thing I will add about discovering primes is that when it's time to do the primes, you don't have to do uh, um all the multiples. You just do square root of 10. um all you need is the square root of 10 multiples. And I'm going to explain a little bit what I mean by that. So the square root of 10, or 210, we can look for the perfect squares to help us know what's the square root of 210. Kind of like a mental shortcut is to think about the perfect squares. So that's why learning your perfect squares is important. So 225 I know is 15 squared. And then 196 is 14 squared. So I know that the square root of 10 is between 14 and 15, somewhere in between. Okay? So that's the base. This is the base of my number. Okay, great. I need to know what prime numbers show up less than the square root of 210. Okay, so primes, we're concerned with the multiples of primes less than 210. So that is going to include That's going to include 11, 7, 11, and 13. So those are the multiples we're going to be concerned with to discover the next set of primes up to 210. Okay? So we can do that, or you could do that as an exercise. See if you can discover the next set of primes using this system. Okay? I want to thank you so much for tuning in to this presentation on how to discover primes, and we'll see you next time.